Hey everybody, today we'll be doing another video, and today we will go back to decimal, right? So in other words, we're going from a computer type language going back to decimal, right? To human language, right? So that's base 16. Okay, now, so I got a 1C base 16, which is hex, and I want to convert this number to decimal, right? So this is a little, well, there is two ways to do this, and I will try to show both ways. One way requires more work than the other. And again, we know that, just let me review a little quick, the hexadecimal and the decimal, right, it's just different. It's just 6-digit greater, right? That's why it's called base 16, right? And the decimal is base 10, right? So the only difference, we're going from 10, or I will say from 11, because remember in the first video I said that technically it started from 0 because we start from 0, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that is counted from 0, right? But if you count 0 as a digit, it's a different thing. You start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then, so this is actually base 10 here, right? Then 16, we got 6 more digits, right? So this is a 10, right? And then we got a 1, 2, 3, 4, 5, 6, right? So we get to 15, but we start from 0. That'll give us 16, right? Base 16. So now we translate this from 10. Starting from 10, we got the same thing in the hexadecimal. So 0 corresponds to 0 on hex, right? 1 to 1, 2 to 2, 3 to 3 in hex, and 4 in decimal correspond to 4 in hexadecimal, 5 and 5, and so forth, all the way down. Now, the only thing that is different is after 10 we start using letters, right? So starting at 10 we start using letters all the way to 15, which is represented by F, right? Now, let's see here. Let me do the way that requires more work first, right? One way is to convert this to binary, right? That's one of the ways, right? So let's do that, right? So okay, so in C, we know that correspond to 12, right? So C is 12, right? Let's see that if you don't know, right? So you don't know, but you know that C corresponds to 12, then you put 12 in there. Actually, you know what? Let me just work this out with a little more space, because it's going to take some space. So C is 12, and 1 is simply 1, right? In the last video, we actually turned on the bit, right? On or off, right? So we started 1, 2, 4, 8. 1, 2, 4, 8, right? So now, what bits do I need to get this, right? So I need what? I need 8 and 4 to get 12, right? So I put 1, 1, 0, 0, right? I don't need those, so I turn them off. Or I put zeros on it, right? That means system off or whatever. Or, program is not running or whatever. Whatever you want to make sense out of this, just go for it. Or true or false. True or false. That's what it means. True, true, false, false. It's all logic in the computer system, right? Now, here you got 1, right? And then that is digits 1, right? That's what I'm looking for. So the only one that I need is 1, so I put 1, 0, 0, 0, right? Now, this is the tricky part. In order to do this, remember, I have to separate them by 4 bits. So I have to put one whole number. Just one number. I put 0, 0, 0, 1, right? And then I bring this here and I put 1, 1, 0, 0, right? So now I have this together, one binary number, right? So this is base 2 now, right? So I went back to base 2. Now, how do I convert this base 2 to decimal? Now, this is the only thing that is that we have to remember. This is that we are not not interested anymore in breaking this into 4 bits, right? We are not doing this anymore in this case. What we're doing is just follow base 2 again, but starting from 0 again, working the way back, right? So here, we know that's 0, so we don't have to, actually what you can do here in this case, because you know that this is 0, this is 1, 2, 3, 4, right? This is 5, 6, 7, but you don't have to worry about that because you will get zeros anyway, right? So don't worry about those. Just put 1 times 2 to the 4th power plus 1 times 2 to the 3rd power plus 1 times 1 times 2 to the 2nd power, right? And you don't worry about the zeros because it's going to be zeros anyway. You multiply by 0, it's going to give you zeros, right? So now that I have this, I can actually do the math here. So this gives 16, so 16 times 1 is 16, right? Then now I am adding the whole thing, like I say. I am adding the whole thing because I want to get the decimal, right? So now I get that is going to be 8, right? And then that is going to be, like I say, this 1 times 8 to the 3rd power is 1 times 2 to the 3rd power is 8, right? And 1 times 2 to the 2nd power is 4, right? Add them together, which is equal to, that is equal to 24 plus 4 is 28. Right? So 28 base 10. So the answer for this is what? It's base 10 because it's decimal, right? So we count our language, right? So that's human being language, the way that we are taught to do mathematics, right? So now, I will say that 1C base 16 corresponds to 28 base 10. Okay, that is the answer for part A. Now, let's do part B, right? Part B. Actually, you know what? Let me do part A using the other method, right? So part A using the second method, right? Part A, we have, the second method is different. The second method is the following. When you have a seed like this, or a letter, this count for one digit in hexadecimal and this count for another digit in hexadecimal, right? That's what we say last time, right? So it is a letter, yes, it's a letter, but what the letter represents? That letter represents 12, right? So if this letter represents 12, then I have to work it out starting from base, from left, from right to left, right? And I have to be able to multiply by the weight. Remember when we did this, we multiplied by 1, right? 1 times 2 to the 0 power, right, is equal to 1. I'm sorry, yeah, it's equal to 1 because any number to a 0 power is 1, so it's equal to 1, right? So, so it's the same concept here, right? Any number to the 0 power in this case, right, is going to be any number is going to be multiplied by that, right? By that number, by 16, right? Because that's the weight. That's the weight, right? So, how we do this, right? So now we know that C is going to be 12, right? So it's going to be 12, right? Times, okay, let me just go back here, right? Because, okay, to this example. This is base 2, right? This is base 2, right? But this one is the factor, right? In binary. In our case, this one here, the C actually is the number that corresponds to the decimal, but not to the hexadecimal, but remember that it's base 16, right? So what I will do here is multiply that by 16 to the 0 power, right? Right? Starting from count this as the first digit, right? Then I add a plus sign, and then I do 1 times. So here is so here is actually any number to the 0 power is 1, correct? So that is give me that number. Now here I'm going to multiply that number here, right? So here I am going to multiply that number 1, and then I am going to multiply that number by 16, right? And what base is this? If this is 0, this is going to be 1, right? So now I do the math, right? So now this is 16, right? Okay, why? Because 16 to the first power is 16. 16 to the first power is just that number, right? Multiplied by 1 is 16. Plus here, 16, right? Let me just work this out. 16 to the 0 power is 1, right? Is 1, right? Now times 12 is just 12, right? And then if I add those two, I got 16 plus 12, which is equal to 28. And that is base 10. Okay? So this is the second way to do the problem. This requires less work, right? Requires less work, right? So that's how we do those problems. Remember the same concept. Here we use in base 2, we're multiplying by the binary. Here we use in base 16, we're multiplying the base by starting from 0, right? And the exponent starting from 0. And then we multiply by the value of the c, which is 12, right? Okay, so that is the second way how to do part A, right? Let me do part B real quick. Okay, part B. Part B is, so here I got 5, I got 8, and I got 8, right? Okay, so if I go back, if I want to go back to the binary type, right? To the binary type, it's going to get kind of messy, but we will do it, right? So here, right? Let's say that I want to do 1, 2, 4, 8, 1, 1, 2, 4, 8, right? And I do 1, 2, 4, 8, right? Alright, so now let's turn on the bits, right? Or whatever you want to say it, you know, want to say zeros and ones, or you want to turn on the bits, turn off the bit, whatever works for you, or true or false, whatever, right? So how do I actually get 5 here? I get 5 by doing this and this, nope, and this, right? Then which means that this is 0, this is 1, this is 1, I'm sorry, this is 0, this is 0, and this is 1, right? Here, how I get 8? Well, 8 is just basically, this is 0, 0, 0, 1, right? How do I get, well, A corresponds to 10 here, right? Actually, we can actually write that number and say that it's 10. Put a 10 in there, right? So because we know that 10 corresponds to 8, right? Now, how do I get 10 here? I get 10 by doing this and this, right? So I do 1, 0, 1, 0, right? Now that I have these numbers, I have to put them together in one whole decimal. One whole number of, not a whole number, but one binary number. The whole thing gotta be one binary number, right? So I do 1, 0, 1, 0. I do 1, 0, 0, 0. I do 0, 1, 0, 1, right? So I got that, and I got that, right? So now that I have this number, I can actually work it out to see what numbers I get values out of this and what numbers I don't get value, because remember, I gotta multiply everything by this type of values. And I know that I got a bunch of zeros, so a lot of numbers are going to be eliminated, right? But what I can do here to kind of shortcut to help me out what numbers I'm going just to eliminate, right? I can actually use this little trick. I can start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay? So and then what I do, I bring whatever numbers I have down and forget about the 0, because I am going to be multiplying by 0, which is going to be, 0, right? Now, here, in this first one, I can say 1 times 2 to the 11th power plus. So this is 0, so I don't have to worry about that. And then, but I got a 9 here. I got a 9, right? This 1 over there, so to the 9th power. So that's correspond, this multiplier, which is 1, correspond to a certain number, which is base 2 multiplied to the 9th power, right? So I get 1 times 2 to the 9th power, right? And then 8 is a 0, so I don't have to do the 8, but I have to do this one, the 7, right? So I have to put 1 times 2 to the 7th power, right? And then all the zeros, I don't have to worry about them. 1, 2, 3, 4. I don't have to worry about them. About this is all a bunch of zeros. So 6, 5, 4, 3. I don't have to worry about it. I don't have to worry about 6, 5, 4, and 3, right? So I just do 2. So I just do 2. 2, right? Actually, to be consistent, just 1 times 2 to the 2nd power, and then I have to count 1, 2. This I don't count this 1, but I count to the 0 power. So plus 1 times 2 to the 0 power, right? Okay, now now that I have this number, it's going to be some kind of big number, because remember I have some high powers here. I got 11. So let's do it with the calculator real quick. Okay, so 11. Okay, so 2 to the 11th power. Right? This number is 2048. Right? Then this 2 to the 9th power is plus 512, and this 2 to the 7th power is 128, but let me verify. So 2 to the 2nd power to the 7th power is 128, and then this is 4. This is 4, and this is just 1, right? Okay, so now when I add those numbers, I get what? I get 2048 plus 512 plus 128 plus 4 plus 1, and is equal to 2693 base 10, right? So this B, right? B, which is A5, corresponds, base 16, correspond to 2693 base 10. Okay, so that's how you do this the long way, right? So that's how you do that, right? So you write the numbers, right, that correspond to the decimal system, do the math, go to binary, from binary you go to whatever numbers you can actually count to base 2, right? And remember, you multiply it by the factor of the binary, so whatever you have is 0, you don't have to worry about it. And then just do the math, right, to get these numbers, and then add them up, you get the total. You add the whole thing, right, because you're looking for the decimal, you get the total, and then you get the answer, which in this case is 2,693 in base 10, right? Now let's do this on the other method, using the other method. Okay, let me do this real quick. So, okay, so here, remember, we have these numbers, right? So we have 1, 2, 3, and then we start again. We start from the first digit to the right. I'm sorry, the first digit on the right to the left, right? So we start with, so we can say 5, right? Times, right? Times 16 to the 0 power, right? And then I said 16 to the first power, right? Times 8. And then you do 10, right? So put a plus sign there. And I know that this 8 is 10, so 8 is equal to 10, right? Now I have to actually go back and say 16, right? So this is, remember, this is power of 0, 1, 2, 1, and then it's going to be 2. So it's going to be 16 to, right, to the second power times what? Times 10, right? Now if I do this math, look how less messy, right? It's already, right? Because this method is easier. You don't have to do a lot of conversion back and forth. But again, whatever method works for you, go for, right? Okay, so this one here, let's do this. So 16 squared times 10. 16 squared times 10, that is 2560, right? Okay, now let's do, okay, so this one is just 16 times 8 plus 16 times 8, right? But, okay, let me just do, separate. So 8 times 16 is 128, right? Plus 5, right? Because, why is 5? Because any number to the 0 power is 1 times 5 is just 5, right? So that is 5, right? Now when I add this together, I get 2560 plus 5, and it is equal to 2693 base 10. Alright, so I like this method better, but again, whatever works for you, just go for it, right? So here we got, again, we found, this is using the second method, so A5 base 16 correspond to 2693 base 10, or 2693 base 10, right? Okay. Okay, that is the quick lesson for today. How to go from hexadecimal to decimal, right? And that's it for today. I hope you learned something in this video, and thank you for watching. If you like this video, subscribe, or share. Share in whatever your favorite social media. Right? Thank you for watching.